a review of atoms and elements part 2. Specifically today we're going to be talking about a review of the mole, then we're going to review the mole in terms of some worked examples. We're going to talk about converting between moles, mass, and particles, and finally wrap it up by looking at some worked examples. Knowing the mole. A mole, or abbreviated MOL, is the amount of any material containing 6.02 times 10 to the 23rd particles, and this was proposed by Amedeo Avogadro. Converting between moles, mass, and particles. Important points to remember when doing conversions. Always remember to show your work. I cannot stress this enough. And make sure to label and check that your units cancel. So we're going to be looking at a given, a multiplication sign, and a line. The units from our given will go on the bottom. The units from our final will go on top. We're going to put our equal sign, and finally, we know our problem is set up correctly if the units from our final is at the end. And make sure you should always be able to look at your setup when doing these conversions and be able to cancel. So units from your given should cancel units from your given on the bottom of this ratio. Let's look at some examples. Given 27.6 grams of argon. So the first thing I'm going to do is rewrite my given. So 27.6 grams of argon. I want to convert this into moles. So I'm going to put a multiplication sign and a line. Grams of argon will go at the top, and I know that we are converting to moles, and 1 mole of any element is equal to its atomic mass, and the atomic mass for argon is approximately 40 grams. And then I'm going to make sure that grams of argon cancel grams of argon. 27.6 times 1 divided by 40 will equal 0.690 moles of argon. So I have labeled all the way through. I have made sure that my units cancel. And finally, noticing that I have 3 significant figures to start with, my final answer also has 3 significant figures. Now let's go in the opposite direction, moles to mass. My given here is 3.5 moles of carbon. I want to get this to mass of carbon, so multiplication sign and a line. I know that 1 mole of anything, in this case carbon, will equal its atomic mass, so 12 grams of carbon on the top. Moles of carbon cancels moles of carbon, equal sign. 3.5 times 12 divided by 1, that will give me 42 grams of carbon. I have labeled all the way through. I have canceled my units. I start with 2 significant figures. I end with 2 significant figures. And remember, the numbers in the conversion are known as exact numbers, and we do not take those into consideration when we are looking at significant figures. We only look at the given when we are figuring out the number of significant figures at the end. Now let's go on and talk about atoms, molecules, formula units, which represents our ionic compounds, and ions into moles. So my first given is 1.6 times 10 to the 24th atoms of silver. So to save space, I'm just going to use that as my given, multiplication sign and a line. I am going to have atoms of silver on the bottom. I want all of these converted into 1 mole. And I know that 1 mole of anything, when I'm talking about atoms, is going to be our 6.02 times 10 to the 23rd. So again, I'm going to cancel. Atoms cancels atoms. I'm going to do 1.6 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. And if you put this into your calculator correctly, if I write out the number initially without thinking about significant figures, I'm going to get 2.657 moles of silver. But again, I look at the beginning, I have 2 significant figures here, so my real answer here when rounding should be 2.7 moles of silver as my final answer. Let's look at the next one. We're dealing with molecules and we're converting into moles. So again, I know I'm going to use 6.02 times 10 to the 23rd. So multiplication sign and a line. If I start with molecules, I'm going to have 6.02 times 10 to the 23rd molecules. And yes, you should write the whole thing out. Molecules of carbon tetrachloride on the bottom is equal to 1 mole of carbon tetrachloride. I want to make sure that my units cancel, so molecules cancels molecules. So 23 times 1 divided by 6.02 times 10 to the 23rd. I have my equal sign, and if I work this out, I'm going to get 3.8 times 10 to the negative 23 moles of carbon tetrachloride. Very small number here, very small number, which makes sense because I'm only starting with 23 molecules. That's like an absurdly small number. Let's look at the last one here. 1.075 times 10 to the 36th ions of chloride. That's a big number. Yes, it is. I'm dealing with ions here. So again, multiplication sign in a line. I'm going to put ions on the bottom. So I'm converting this into 1 mole of chloride ions. So I'm going to have 6.02 times 10 to the 23rd ions, Cl minus on the bottom. Ions cancel ions. 1.075 times 10 to the 36th times 1 divided by 6.02 times 10 to the 23rd. And if I work this out, I get 1.786 times 10 to the 12th moles of chloride ions. So again, I made sure that I wrote everything out. I make sure that my units cancel. I'm left with the unit that I want in the end. And this is a review of converting atoms, molecules, and ions into moles. So when I see these words, that's a big trigger to use Avogadro's number. Let's do some more examples. In this case, we're going to go from moles to atoms. Our given is 3.6 moles of xenon. So 3.6 moles of Xe, multiplication sign in a line. If I'm starting with moles, 1 mole of Xe will go on the bottom. I'm converting this into atoms. And again, when I hear the word atoms, I'm going to use 6.02 times 10 to the 23rd atoms. I want to make sure that my units cancel, so moles cancel moles. I'm left with atoms, which is what I want. So if I do 3.6 times 6.02 times 10 to the 23rd, my answer will be 2.17 times 10 to the 24th atoms of Xe. But that's not to the correct number of significant figures because I have 3.6 at the beginning. That's 2 significant figures. So the final answer here to the correct number of significant figures should really be 2.2 times 10 to the 24th atoms of Xe. Let's look at the next one. Moles to formula units. Remember, formula units represent ionic compounds. Ionic compounds, when we talk about them, we refer to them as formula units. So my given here is 8.1 moles of KClO, multiplication sign and a line. 1 mole of KClO on the bottom. I'm looking for formula units. So 6.02 times 10 to the 23rd formula units. Yes, I am writing the whole thing out. I want to make sure that this cancels, so moles cancel moles. So then I'm going to do 1.8 times 6.02 times 10 to the 23rd. And when I do this, I get for a final answer of 4.9 times 10 to the 24th formula units of KClO. Last one. Moles to ions. My given here is 24 moles of phosphate ions. So I'm going to rewrite my given. 24 moles of PO4 minus 3. Multiplication sign and a line. I'm starting with moles. So 1 mole of PO4 minus 3 on the bottom. I'm dealing with ions. Again, another trigger to say you're going to use 6.02 times 10 to the 23rd ions of PO4 minus 3. I'm going to check to make sure my units cancel. Moles, cancel, moles. I'm going to put my equal sign. 24 times 6.02 times 10 to the 23rd divided by 1. If I work this out, I should get 1.4 times 10 to the 25th ions PO4 minus 3, and I check to make sure that I am starting and ending with the correct number of significant figures, which I am. And this is a review of converting moles to atoms, moles to formula units, and moles to ions. So what did you learn? We reviewed the concept of the mole. We did some worked examples with the moles. We converted moles, mass, and particles. And then we did some worked examples with that. Need more help? Feel free to contact me. Have a great day.